All right, everybody. Let's do this one with sound. I've already given my best effort today. I don't know. I feel like you guys are getting ripped off here. I left it all at my desk in the office, and you're just gonna get a second-rate performance tonight for a final lecture. Sorry about that. I feel terrible. Um, but seriously, apologies for the technical delays. Welcome to the last lecture for ENVS 1030 and 1100 for the fall semester of 2021. I wanted to wrap up by talking about invasive species for a couple of reasons. One, it's topical. There's still a fair bit of interest in invasive species and their effect on the structure and functioning of ecosystems. Two, they bring together the two aspects of environmental sciences that I see as dominating the field, and that is kind of that ecosystem, biogeochemical cycling, energy cycling approach, kind of ecosystem science approach, and the community, population, ecology, biodiversity, food web kind of side of things. And it brings them together because invasive species, if they do have a large impact, will impact both the energy flux and the nutrient cycling and those elements of the food web that we're concerned about, and have impacts on the biodiversity and the abundance and distribution of other organisms. So to me, it's an interesting case study that brings them together. It's also, to me, an interesting case study because it highlights a couple of aspects of environmental sciences that I think we want to be aware of as practitioners, and it shows that people can have different viewpoints, and to debate rationally the pluses or the costs and benefits of conducting different types of research and different types of management and policy actions, and hopefully have a fruitful discussion about these things, and to be aware that there are cultural and emotional underpinnings to a lot of the ways we view and value ecosystems in the environment. So hopefully I'll touch on this today, and I'm going to do it by taking you through some discussion points from a round table that was conducted, when was it, 2007, somewhere in there. So getting a little older, but still pretty relevant when it comes to the way we think about invasive species. So there were actually four panelists, or four members of the round table. I only highlight comments from three of them, not because of anything that Dov Sachs says is wrong, but I think that just between Jim Brown and Dan Simberloff and Mark Sagoff, I kind of capture a lot of the discussion that went around here. And so these are all pretty big thinkers, pretty interesting people. James Brown is one of the, if not, one of the most famous ecologists in the world. James Brown's a professor in New Mexico. He might even be emeritus by now. I'm not even quite sure. But he really, throughout the 90s and the early 2000s, took the field of what's called macroecology, which is looking for broad scale patterns between the size of organisms in the environment and different kind of metabolic properties and different ecosystem properties, and he kind of developed this whole science of macroecology and making generalizations about ecosystems and food webs based on limited information. So arguably, you talk to anybody who's an ecologist, and they'll know who James Brown was. 2001 won this Eugene P. Odom Award, which is basically best ecologist in the world. When asked if biological invasions decrease biodiversity, he had a bit of an interesting answer, which was yes and no. And when I was studying species invasions a little bit and discussing it with species invasions ecologists, this was one thing I couldn't really get my head around at the beginning, but the more you think about it, the more mathematically it makes sense. But the first point that James Brown said, first he goes yes and no. First of all, we're not very good at predicting what happens when a species invades. We're not very good at predicting if a species will be successful. And then if we're right about it being successful, then we're usually not that good at predicting what the consequences will be. That being said, there's a certain I think media attraction to stories about invasive species, and as we've seen from our media article analysis, those descriptions might be a little hyperbolic. So do biological invasions decrease biodiversity? So globally, yes. I think that's the first answer, is that globally biodiversity is decreasing as a result of human-assisted invasions. However, locally, the extinction of native species has typically been more than offset by the colonization of invading species. So it's interesting that locally, some species may go extinct as a result of invasive species establishing themselves. But in any one given environment, the number of extinctions resulting from invasive species is outnumbered by the number of invasions. So you actually tend to gain species as a result of species invasions. So it's true for continents as well as for islands. North America has more bird and mammal species right now than it did pre-European contact. California has 1,000 what they call naturalized exotics. And all naturalized means is that they grow on their own there, but they're exotic, and we can call them invasive if you want. So 1,000 of 6,000 plant species are naturalized exotics. And in the state of California, only 30 native species are known, we'll give you that, but are known to have gone extinct. So you've gained 1,000 species, but lost 30. Anywhere you go, invading species has approximately doubled the island, the number of species on flora on islands. So in Hawaii, you go from 1,300 to 2,300, Easter Island 50 to 111, New Zealand 2,000 to 4,000. So from a species diversity point of view, species invasions has resulted more often in increases in biodiversity as opposed to decreases in biodiversity. So that does beg the question, how can that be? And you know, you talk to James Brown here, and he'll tell you about the continually like over geological time scales, shifting and balancing, filling and emptying of different habitats of species invading or immigrating, or you know, evolving, and then extinction and emigration. And one of the questions that we don't actually have a great handle on as ecologists is how, in all of this shifting, how full are ecosystems? Because if ecosystems are full, like jam-packed, no room at the hotel kind of idea, then if a species comes in and successfully invades, then at least one other species will have to be booted, right? That's kind of, or something like that. Conversely, if ecosystems are not full, there could be ecological space there for exotic species to take up ecological space. So James Brown thinks that most ecosystems aren't that full, and that invasive species can successfully establish and not necessarily do any harm to native species. And that'll be more the case, more often than not the case. His take is that, you know, invaders often evoke this strong emotional response, even from normally objective scientists. We tend to be protective of our ecosystems, and we think that anything that comes in is bad, right? Because the lake I grew up beside never had round goby, so round goby's bad, right? And that is an emotional response. Brown's not saying that naturalized species are necessarily desirable, or that we shouldn't try to prevent immigration or eradication of foreign species, but saying that we need to do some more scientific studies and also prioritize what we do want to study, and to figure out where invasive species are on kind of the list of pressing environmental issues. So Brown has 6 conclusions from the current data. So many places have experienced extinctions of native plants, fish, birds. Alien species have undoubtedly contributed to this. So he's like, yes, with absolutely invasives at some level contribute to the extinction of some organisms. Despite those local extinctions, generally speaking, the number of species usually increases or remains at the very least the same in those areas. So although we often accuse invading species of damaging the structure and function of ecosystems, there's very little evidence to this. And there actually seems to be some evidence on some islands suggesting that there's really no, our understanding as to how alien species impact local biodiversity is we're still not quite there. However, the net effect is globally, right? Even if your ecosystem gains 100 species and only loses 1 species, but your ecosystem is the only ecosystem that has that species, the planet loses that species, right? So we are talking homogenization here. This cross-pollination type of diversity resulting from human movement across the globe will have a short-term increase in biodiversity effect, but yeah, we're not quite sure what the effects of that will be. And we don't know how much longer that will, we're in a bit of a transient phase right now. So that was James Brown. So Daniel Simberloff has a bit of a different take on things. So imagine him sitting at the same table. He's the director of the Institute for Biological Invasions, so you can imagine that he thinks that biological invasions are important things to study. He has a long and storied career as an ecologist, doing a lot of island and archipelago work, a lot of experimental stuff on small ecosystems, and then started to do more conservation ecology in the 90s. He definitely thinks that biological invasions have real impacts and important impacts on local ecosystems, but he is a great believer in our ability to manage, prevent, eradicate invasive species. So he takes a bit of a different approach compared to James Brown. The thing about Simberloff is that he I guess we would call it a precautionary principle. He calls it a guilty until proven innocent principle in dealing with invasive species. So I'm sure that after all of our discussions of the precautionary principle, you're very clear on what that means. But in this particular case, what Simberloff is talking about is being very conservative when it comes to movement of organisms around the globe and preventing that movement. So Simberloff, when you have discussions with him, says, yeah, I mean, the most introduced species likely don't have a detrimental effect on the local ecosystem structure and function. But his thought experiment is, let's say it's only 10%. 10% doesn't seem like a large number, but 10% of a large number is still a large number. So given that the US has 6,000, probably way more than that, but documented introduced species, that means that 600 are a problem. And if you have 600 different species across how many different ecosystems, across how large of a footprint, it's going to be an ecological concern. It's going to be an economic concern. Depending on what the invasive species is, it could be a social concern too. So Simberloff says, okay, we're not saying that every single species that's invasive is going to, destroy every single ecosystem, but this is a large problem and we have to deal with it. He tried to get out in front here in Mark Sagoff, who's coming up. Daniel Simberloff is kind of making reference here to the fact that some people who have talked about invasive species have criticized the scientists' use of terms that could be construed as biased, or even as far as xenophobic or racist. So Simberloff here is he's trying to kind of ward off an argument that Sagoff's going to bring forward later, saying that no, this is not what we're talking about. Invasive species have real ecological and environmentally important effects, and that's what the discussion should be about. And he says, within California itself, There's so many examples of plants as threatened species, and the invasive species that are directly depressing their success in their home environments, and that even birds are being threatened as well, with an estimated 12% of the world's species threatened with imminent extinction, and 510 of these species, the threat is wholly or partly from introduced species, whether that's predators or competitors or herbivores, whatever that is. So that's, Simberloff is saying this is not a small issue. This is a big issue. In terms of the extent to which these species are specifically threatened by invasive species, like how much can we blame invasive species? It's tough to say because it's a multivariate problem, where you have environments changing at the same time that invasive species are coming in. So partitioning out the degree to which climate change versus invasive species has contributed to a certain species decline is pretty difficult to do, and the evidence is often anecdotal or speculative or based on limited observations, linking invasive species to extinction events or threatened species. But and this is Simberloff playing the devil's advocate, basically saying, well, the same could be said of the link between habitat destruction and extinction, or pollution and extinction, or diseases and extinction. We as environmental scientists and ecologists, we don't have great cause-effect linkages, specifically because they are very, very complex systems. And we just have to be vigilant about doing as much as we can to prevent any extinctions. And that would include keeping our eye on those invasive species, because if we don't, then we're going to miss species going extinct, and the last individuals of a species almost always disappear when no one's watching. So that's Simberloff's appeal, is that to the ecologist and to the general public, is that take this seriously, because this is a real ecological threat. He said, many introduced species, we didn't even know that they were going to be a threat for decades. And then all of a sudden they take off. And so we're not very good at predicting whether things are going to become, I guess there's a difference between just successfully invading and becoming, a threat to ecosystem structure and function. And we're not very good at predicting that quite yet, right? If it were, we'd be straightforward. We'd be able to say, okay, we don't want, garlic mustard brought over to southwestern Ontario. Okay, we know that's going to end up being a problem, but we didn't know that. We weren't good at predicting that. We've made good progress, but our predictive tools are still pretty coarse. After the fact, eradication is extremely difficult. I'd say in most cases impossible. You're pretty much stuck with what you have. And so what Simberloff basically says, for at least for the next few decades, we should assume that most established introductions are irrevocable. So that that is Simberloff's approach, and so he is a bit much more cautious than Brown is. And even to the point, and this I think is a little bit more of a contentious issue, but it's an idea. Simberloff says we shouldn't have blacklists, right? That where we have blacklists where species we know we don't want are not allowed. We should have white lists, which are species that we do know enough about to allow into our countries, our jurisdictions. So we have it backwards by having these signs like, ban this and ban that and ban the other. We should be actually saying, no, only this is allowed in, only this is allowed in. I don't know how effective that would be, but it gives you an idea of what Simberloff is thinking. He does acknowledge that there could be problems, with this, the type 1 and type 2 error, where some species denied whitelist status could have been proven innocuous, and others that were granted status could be proven to be a mistake. But, he says it's our obligation to act on this. And, we could all make mistakes, but that shouldn't paralyze us from moving. He argues that just as with global climate change, that if we don't do this, it'll be more expensive in the long run. And, he says that this is the consensus of ecologists, and that there may be some that try and downplay the importance of invasive species, and they get a little bit too much attention. That this is a done deal, and that we shouldn't be really even making an issue of this. So finally, we have a bit of a different take here, and this is Mark Sagoff, who is a philosophy and public policy professor in Maryland. He is not an environmental scientist, so he actually claims that ecology is historical and not a theoretical science. So Mark and I might differ on a few ideas about what ecology is and what ecology isn't. When asked, are non-native species harmful? He said, really that depends on your perspective, right? His take is that this kind of dictum that invasive species are bad, invasive species are bad, invasive species are bad, has been repeated so often that everyone just assumes that it's right, and that it's actually not, and that the science kind of might actually show otherwise. He also claims that there is this linkage between the terminology of invasive and extinction and terms like that that biologists use that kind of might harness a certain mobility in the population that we should maybe think about a little bit before we go using these terms to eradicate organisms. These are value-laden terms, and yeah, they maybe we should think about the way we're referring to these terms. And when Mark Sagoff, as a non-ecologist, non-environmental scientist, went into the literature and looked through the research that was actually done, he was like, what he saw was confirmation bias, and that the definitions as to whether or what was harmful because it was present after a species had established itself, and then when the species established itself more, then whatever the characteristic of the ecosystem would increase, so it would become more harmed. And he kind of saw this circular reasoning in a lot of these studies. And he said, if you look at a lot of these studies, that there's not a lot of evidence for harm from the establishment of these species. And he claimed that a lot of the science is based on cherry picking of data and cherry picking of individual studies, that kind of fuel a bit of confirmation bias. He argues that as scientists, we should be doing this type of thing at random. But the reality is, of course, at this point, we don't have enough scientific studies, in the tens of thousands to be randomly sampling to see whether or not we have bias. We just don't have that sample size. But his point is taken that we should be aware of the studies that are getting funded and the studies that are getting published in terms of the results. And, fair enough. I think that's fine. His example, interestingly, is the Great Lakes. And says, what? Let's think about the Great Lakes and one of the villainous stories of the zebra mussels. And he said, well, up until, the late 70s, eutrophication plagued the Great Lakes. These lakes and these rivers and streams were filling up with algae and becoming green clogged messes. And we were starting to do something on the landscape about that, but what really established was zebra mussels. And with their incredible filtering capacity, they filter enormous quantities of water, and clear out the water column, which probably help things out. So zebra mussels establishing right in the Great Lakes, and this is an interesting one too. When I said back at the beginning of the lecture, right, this linking of the effects on nutrient cycling and energy on one side, and then like species diversity and community and ecology on the other. So here's a great example of zebra mussels, right? And they're having a negative effect on the red boxes and a positive effect on the blue-green boxes. So what you can see, right, is that physical chemical element, the ecosystem type element, dissolved oxygen, they have like a negative effect, or the negative effect on dissolved oxygen, but then on soluble phosphorus at the bottom there, the soluble P, they have a huge positive impact on. So those ecosystem elements. And then on the other side, from the ecology side, they've got a positive effect on the fish, littoral fish populations, and a negative effect on the pelagic fish populations. So it's an interesting kind of study here on how zebra mussels affect the ecosystem as a whole. But interestingly, actually, hold on a second. I'm going to take a pause here, and I'll pick this up in a part 2. Okay. My apologies for that. Family things happen. Okay, so where did I leave off? I believe I left off talking about zebra mussels, ecosystem effects, zebra mussels, biological effects. And what our friend Mark Sagoff was saying was, you know what? Like, zebra mussels were actually a pretty good thing for the Great Lakes, because when all of this comes out, all of these effects come out, you actually get clearer lakes, which is what you wanted at the beginning. And if you look at like water clarity in Lake Erie, and what we've got is we've got 4 different graphs here going from Western Lake Erie at the top to Eastern Lake Erie at the bottom. And zebra mussels year after year, basically they established at the western side and they moved east, gradually year after year after year after year. But what you can see on the y-axis here is how much phytoplankton, so that's how much floating photosynthetic algae is in the water. So, that green eutrophied, yucky water, which was what Lake Erie was famous for, right? And those like right back here, right? Like that green mucky water, that's what it was like in the 60s. The bottom left-hand corner here is the 60s, and then it goes 70s, 80s, 90s. And what you can see is where zebra mussels, whatever year zebra mussels established themselves, that was the year that the water clarity increased incredibly, right? The phytoplankton density decreased because the zebra mussels were just filtering the water, right, and clarifying it. So they, in almost immediately upon establishment, cleared the water as much as the US and Canadian governments wanted to do through a whole bunch of policy regulation, right? So Sagoff says, okay, well, there are people who talk about how expensive it is that zebra mussels got into the Great Lakes. And the estimates wildly vary. In 1993, a congressional report estimated about $300,000 per year. Really nothing at all. But currently estimated $1 billion a year. We're talking that's a pretty good chunk of change. But that being said, how much would it have cost to clean up the water in Lake Erie? Or Lake Ontario, for that matter, when they got in there, and now Lake Huron. We would have been spending money on programs aimed at eutrophication that we didn't have to spend money on. So you know what? Maybe zebra mussels weren't actually that bad, and that this stereotyping, the stereotyping of organisms coming in and being harmful might just be a little, we should make sure we're not biased about this, right? We do worry about, ecologists worry about weedy species and invasive species. We do, but what if it's, we should examine why we're uncomfortable with it, right? We can give aesthetic, moral, spiritual reasons for keeping species in their original environment. But what does define, weediness scientifically? I think of, and I think the same way about some commercial ventures. I do like my diversity. I don't like things that spread globally. But I have to check my own bias there, and make sure that I'm not, and make sure that I'm absolutely certain of what I'm valuing and why I'm valuing it, and to make that argument as to why I think that certain models are bad. Just like I did have to think about why I thought what I thought about invasive species and how I think about invasive species now. So things to think about, right? I mean, there are still lots of programs out there aimed at the control of introduced species or invasive species, or however you want to refer to them. And these are things that I think should perpetually be examined. And in a management sense, I think we have to be very clear about what our desired outcomes are. Because if we are spending millions of dollars a year to control a species that really isn't having a detrimental effect on local flora and fauna, well, maybe those resources could be better spent elsewhere. And then we just have to decide where the burden of proof lies, right? Do we have to prove that a species is having a detrimental effect, Or should the burden of proof be on to say that something doesn't have an effect? So I think that quantifying those risks and benefits is, well, like as with any kind of quantitative game, whoever gets to choose the metrics that you're measuring in terms of how you're defining success or failure, that's going to determine how we're going to move forward. And to think about it, for you, is it a high priority? Why? Why not? And this will change throughout your life, I'm sure. It's changed throughout mine. In terms of the priorities that you think about when you think about environmental science. And there's no right answer here. This is where you get your critical thinking cap going. This is where you start thinking about invasive species and what are we concerned about? Are we concerned about their effect on other local species? Are we concerned about their effect on nutrient cycling, on nitrogen or phosphorus or eutrophication? Are we concerned about aesthetics? What are we, what are our goals, and how can we go about attaining those goals? And once you kind of figure out what aspects of the environment you're concerned about, that'll help you decide what issues are high priorities for you and which are not. Okay, I'm going to leave it there because I've got to go make dinner. It has been a pleasure and a privilege to be your prof for this course. I know what a privilege it is, and I do take it seriously. So yes, please come see me if you ever want to talk about lakes and fish and environmental science, and or not, or you just want to talk about the environmental science program or research or Guelph or anything at all. My door is open, and you've been my student, so that gets you in the door. All right, everybody, take care, and we'll see you sometime in the future without masks, even maybe, hopefully. All right, take care, everyone. Bye-bye.